All right. So notice in this title it says mass calculations. And what this question implies is that we will be starting with a grams. We will need a molar mass to turn it into moles. We will use the mole ratio to work our way across. And then we will do a second calculation with a different molar mass to finish the problem. So it will have three calculations. We will use the same molar mass triangle, but we will need two different molar masses. So we might have to do a couple of little calculations there. Again, I have two examples, but I think we might be able to get it across in just one example. Again, don't worry about this, right? If we're not in moles, we need to change it to moles using the appropriate mathematical equation. We know that. So let's bring this question up here. We'll get rid of that there. And I'm a little concerned that I can't write on the, oh, I can. Perfect, it's in a good spot. Mm-hmm.
If we have to make the equation on our own, is all the reactants going to be included in the question? Or will we have to come up with, like, would you make it finish a single displacement reaction or whatever?
No, I would give it to you. If I'm asking you to do a balanced chemical equation, it would be a pretty straightforward, simple one. Would it be a double displacement? Not likely. It would. What I would give you is, I would tell you what the reactant names are and what the product names are, and you'd have to come up with the formulas and balance it.
Okay.
I wouldn't make you complete a double displacement reaction. The only time I'd make you do that is maybe on a final exam after you've restudied double displacement reactions in order to do that. You see what I mean? But if I'm going to make you do a stoichiometry problem and I'm going to make you do a balanced chemical equation, I would, in the word problem, tell you what the reactants were and what the products were, and then you'd have to come up with the formulas and balance it. So I wouldn't make you predict the products, okay? All right, so we have determined the mass of sodium carbonate, and we want to produce some sodium nitrate. So again, keep in mind, we have our two lines that exist. We've got the mole line and we've got the grams line. So determine the mass of sodium carbonate. So sodium carbonate, determine the mass, question mark, grams. And we know that we're going to try to produce 120 grams. All right? Now, I can only begin where I have information, so my arrows are going to travel down and over to the unknown and back up, right? Because that's where I'm heading. That's what the map is designed to do. So I'm going to head down here and turn it into moles. And again, I need the triangle. Molar mass is grams per mole. So maybe under this area, I would put the equation that I need. So I'm trying to find moles. I cover up moles. Moles is equal to grams divided by molar mass. Now, because I'm under the sodium nitrate, I'm going to need a molar mass of sodium nitrate. So we'll do that first. So we'll break it down into little chunks. I'll write it over here off to the side, NaNO3. And I'm going to be squeezing it here. I apologize. 16 times 3. I dropped the 0.0. 14 times 1. And I believe 23. And I get the weird impression we've already done this mass. What is it? 85? 85 grams per mole. So now we're ready to complete that calculation. 120 grams of the substance, 85 grams per mole. So how many moles do we have? Waiting patiently. What do you got, Amy? 1.4? 1.4 moles. And yes, it's nice to put what it is, NaNO3. All right? I would write that in this spot at this point. I would write 1.4 in that spot. Now I have to move across. X moles. And I like to write up here what that is. What do we call that we use going across? Mole ratio. I get that mole ratio from the coefficients of the equation. X over 1.4 is the same as 1 over 2, right? X and the number. If we could squeeze it under here, that'd be great. Now, I'm running out of space, but you guys, I write pretty big on the smartboard. That's just kind of the way that goes. So I would like to write it into this space here. I'm going to, oh, don't do that. Don't do that. Oh, you silly machine. It thinks I want to do a click. Oh, no. Oh, no. Okay, good. Okay, I'm okay. So, wiggle, squiggle. So I'm going to do X over 1.4 is equal to 1 over 2. Right? Did I do that right? We know that this is going to come up here. Let's save some time. You can do that in your calculator. If you really have to move it, you can, but you don't have to. 0.7. 0.7. Again, with the significant digits thing, it would actually have a 0 on the end because it's exactly 0.70. That's just me being picky. But if you didn't put the 0 on the end, it would be okay. That means I have 0.70 moles at that point there. Now I'm heading up. I don't need to redraw the triangle. And this time I'm trying to find grams. Grams is equal to molar mass times moles. Once again, we need a molar mass, but this time I need the molar mass of sodium carbonate. So I need to do another molar mass determination. And I'll do this way down at the bottom here. Na2CO3, 16 times 3, 12, 23 times 2. And again, I'm tight for space. What do you got? 106? 106? 106 grams per mole. 106 times 0.7. Yeah, go ahead. Yep. 74.2 grams of Na2CO3. And as you can see, this is visually a crazy looking page of calculations. So again, if we're doing a test or something, I'd like the box around the final answer. That helps us track it down. So all we did now is put the 3 together. Some important things to know. When you're moving up and down, you're going to use your grams per mole triangle. When you're moving up and down, the molar mass you use is of the chemical you are below. That's why we build it that way. So here we needed the molar mass of sodium nitrate, and the last step we needed a molar mass of sodium carbonate. And in the middle, we do the mole ratio. X over 1.4 is equal to 1 over 2, and you just carry your calculation over. There is a second example on this note, but you know what? I think we're okay. I think we've got the steps. I don't think it makes sense to do another one at this point. So then you can work for the last 15. If you've got like a 1-to-1 or a 2-to-2 or a 3-to-3, yeah, then the moles don't change. Yep, they don't change at all. Because when you bring that up to the other side, you're just going to be times 1. Yep. I'd like the picture taken of it, but you can do it by paper. You can do it by paper. When do I have it due, though? I have it due like Sunday or Saturday? Saturday, because I wanted to mark it on. If you can take a picture, that'd be great. If I can't see the picture and it's a really terrible picture, then I'll gather it up from you on Monday. You could give it to me now if you wanted to. Sure. Yep. Yep. If you're done. Okay. So I'm going to stop my video and deal with that.